Hi everyone, welcome to DVS Math.
So in this session we are continuing the exercise 2.3 in triangle lesson. In previous session we solved question number 2. Now we are moving on to the next question. It is question number 3. So observe the question clearly here. Diagonals AC and BD of trapezium. So observe diagonals of AC and BD of a trapezium ABCD with AB is parallel to DC. As you all know, if you are considering any of the figure as a trapezium, one of the pair must be a parallel. So definitely here AB is parallel to DC and intersect each other at point O. That means the diagonals AC and BD are intersecting at point O. Using similarity criterion of two triangles, show that OA by OC is equal to OB by OD. Okay. That means understand the question. Here they are saying two diagonals AC and BD of trapezium. Here the diagonals are related to the trapezium ABCD, and here they are saying that this AB is parallel to DC. As you all know, in trapezium one of the pair must be a parallel, right? So here AB is parallel to DC and these diagonals are intersecting at point O here. Okay, so now using the similarity criterion, we have to show that OA by OC is equal to OB by OD. So now let us, as you all know, if it is show that and prove that, every time you have to mention the given, to prove and proof. Clear? So now let's move on to the given. What is the given? ABCD is a trapezium, as they said that trapezium, and AB is parallel to CD. Yes, AB is parallel. Everything it will be in the question only. No need to and here only the given, you have to copy the given part from the question itself. The question is saying that ABCD is a trapezium, AB is parallel to CD and diagonals AB and CD intersecting at O. And for this you have to write the figure, that is the trapezium ABCD is a trapezium. Then join the diagonals at point O. This is the simple figure, and this figure it is not mentioned here in the question or textbook. We have to write here. So observe carefully, write the trapezium figure and intersect the two diagonals at point O now. Okay. So now you can observe here. What does to prove? To prove is also it is in the question, that is OA by OC is equal to OB by OD. So now what is the proof now? Let's go on to the proof now. It is, and this is very simple problem. So what is the proof? That is we have to consider two triangles. And how to consider those two triangles means you have to consider the parallel lines together. So which is the parallel line here? AB and DC, right? So we are considering these two triangles. That means triangle OAB, that is triangle OAB, and triangle OCD. So we are taking two triangles. As you know, first, as you all know, the similarity criterion we have to use. So you can take the ratios of their sides or you can take their angles also. So now for using the angles, here we are taking the first angle, that is angle AOB is equal to angle DOC, which is vertically opposite angle. This is the first one we are taking. Next one, angle ABO, and here remember we are saying these two sides are parallel, that is AB is parallel to DC. That means here BD or AC, that is diagonals, looks like a transversal, right? It looks like a transversal. As if we consider they are a transversal, as you all know, alternate angles are equal, right? Alternate angles are equal. That means here you can consider two alternate angles. That means here angle OAB, or you can consider OCB. Okay, or you can consider this one OBA or ODA. Clear? So you can observe here. So first we can consider any one, because if it is Aa similarity also we can prove that those two triangles are similar, right? So here you can consider ABO is equal to CDO, that is ABO. So that is this angle is equal to this angle CDO. So these two are alternate angles. You can write it as alternate angles. That means one is vertically opposite angle, one is alternate angles. That means two angles are equal. Then finally, and you can consider another angle also. You can stop for two triangles. Remember, if you here in triangles, if you consider any two angles also, if they are equal, then you can conclude that those two triangles are similar. Or if you need, you can consider another angle also. Here they consider BAO, that is BAO, you can consider this and this are also alternate angles. So by Aaa similarity theorem, these two triangles are similar. These two triangles are similar. That means the first one is vertically opposite angles are equal. Number 2, if AB is parallel to CD, then the diagonals will be the transversal. If diagonals are transversal, you can consider the alternate angles are equal, and using the Aaa similarity theorem, you can conclude that these two triangles are similar. So now, if you know that those any two triangles are similar, their corresponding sides are in the same ratio, right? As you all know by BPT, if two triangles are similar, so what we concluded? The two sides are in the same ratio, or if you consider a parallel, or in the Aaa similarity also, you can consider if two triangles are similar, then their corresponding sides are in the same ratio. So here what we are uploading is, if two triangles are similar, their corresponding sides are proportional, are in proportional. That means what are the corresponding sides now? So in these two, if we consider these two triangles now, triangle 1 and triangle 2, so if they are similar now, according to by Aaa similarity, we proved these two triangles are similar. Now you have to consider their corresponding sides. That means if you consider AO, okay, for this, so for this triangle it becomes OC, so OA by OC. Or if you consider OB of this triangle, OD becomes of this triangle, so OB by OD. So this is our proof. So hence proved. So here observe carefully. First take the alternate angles are equal in this case, then take alternate angles, vertically opposite angles are equal, alternate angles are equal, then prove that by using Aaa similarity theorem, these two triangles are similar. Then if any two triangles are similar, then their sides are in proportional. So taking their half of the diagonals in each side and take their ratios are proportional. So hence proved. Clear? So this is about question number 3. Exercise 2.3.
For more exercise questions, subscribe my channel. Keep watching. Thank you.